Hello everyone, myself Vikas Kumar and I am studying in 4th SEM ISC. Subject is Analysis and Design of Algorithms. Topic is Decision Tree. Overview of decision trees. Definition. A decision tree is a flowchart-like structure used for decision making and predictive modeling. It visualizes decisions and their possible consequences, including chance event outcomes, resource cost and utility. Purpose. Classification. Assigning labels to data points based on feature values. Example, spam versus not spam in email filtering. Regression, predicting continuous values. Example, predicting house prices based on features like size, location. Key components. First node, root node, the topmost node representing the entire data set. It splits into branches based on feature values. Second one, decision nodes, intermediate nodes that represent a decision or a test on a particular feature. Leaf nodes, terminal nodes that represent the final output or prediction. Edges or branches connects nodes and represents the outcome of decision or test. Each branch corresponds to a possible value or a range of values for the feature being tested. Components of decision trees. Root node. Description. The starting point of a tree. It contains the entire data set and is where the first decision or a test is made. Function. Determines how the data is split based on chosen features. Second, decision nodes. Description. Intermediate node that represents a tree or a decision on a particular feature of datasets. Function. Each decision node splits the data set into subsets on based feature values or thresholds, directing the flow of the decision process. Leaf nodes or terminal nodes. Description. Endpoints of the tree that represent the final outcome or prediction. Function. Provide the classification label or predicted value. Fourth, branches. Description. The connections between the nodes that represent the outcome of a decision or a test. Function. Show the path from the root node through the decision nodes to the leaf nodes. Splitting criteria. Rules or merits used to determine how to split nodes. Function ensures that split results in a subset that are homogeneous as possible with respect to pruning. This the process of trimming trees to prevent overfitting by removing the nodes that provide the power. Function simplifies the tree, making it more generalizable to new data. How decision tree works. Building the tree. Step 1. Start with the root node. Begin with the entire dataset at a root node. Step 2. Split the dataset. Using the splitting criterion to divide the data into subset based on feature values, the goal is to find the best split that maximizes the separation of classes or minimizes error. Step 3. Create a decision node. For each subject, create a decision node that tests additional feature. Repeat the splitting process for each node until certain stopping criteria are met. Step 4. Splitting nodes. Once the splitting criteria are no longer met, or if the nodes are pure, create a leaf node that provides the final classification or prediction. Second one, splitting criteria. Classification trees. Gini impurity measures the impurity of a node, aiming to minimize it. Information gain based on the reduction in entropy after the split. Regression tree, mean squared error, measures the average square difference between observed and predicted values. Third one, example flow. Initial dataset. Example, dataset with features such as age, income, and educational level. First split. Example, split based on income greater than 50,000. Subsequent splits. Example, further splits based on age less than 30 or education equals high school. Terminal nodes. Example, final decision might be high risk or low risk for a loan application. Type of decision trees. First one, classification tree. Purpose used for categorizing data into predefined classes or categories. Output class labels, key metrics, Gini tree measures the frequency of incorrect classification, entropy and information gain measures the uncertainty and reduction in uncertainty splits. Example, email spam detection, disease diagnosis, customer segmentation. Second one, regression trees. Purpose used for predicting continuous numerical values. Output continuous values. Key merits mean squared error, mean absolute error. Mean square error measures the average squared difference between actual and predicted value. Mean absolute error measures the average absolute difference between actual and predicted values. Example, forecasting sales, estimating property value, predicting temperature. Third one, difference between classification and regression tree. Output type, classification tree, discrete labels or categories, regression tree, continuous values. Splitting criteria, classification trees based on merits like Gini impurity or information gain. Regression trees based on merits like MSE or MAE. Elements of decision tree. Decision node, branch, decision nodes, leaves. Decision node first condition or a choice, then alternatives, last are decisions or outcomes. Building a decision tree. First, collecting data. Objective, gather the relevant data that will be used to build the decision tree. Consideration, quality ensures the data is clean and accurate. Features, identify relevant features and target variables. Choosing splitting criteria. For example, Gini index measures the impurity of a node. Information gain measures the reduction in entropy after a split. For regression trees, mean squared error measures the variance of a prediction errors. Mean absolute error measures the average absolute difference between predicted and actual values. Creating a decision node process evaluate each feature to determine the best split that maximizes homogeneity with the subsets. Strategy, using the splitting criteria to select the feature and threshold that best separate the data. Fourth, pruning the tree. Objective, simplify the tree to avoid overfitting and improve the generalization. Types of pruning. Pre-pruning stops the tree from growing once it reaches a certain depth or if a node does not meet minimum sample threshold. Post-pruning. Remove nodes that provide little additional value after the tree is fully grown. Benefits, reduce complexity and improves performance on unseen data. Evaluating the tree. Cross-validation. Using techniques like k-fold cross-validation to access trees performance on different subsets of a data. Performance matrices. Evaluate accuracy, precision, recall, F1 score for classification, or MSC or ME. Example processes. Initial datasets features age, income, target, loan approval. First split based on income greater than 50,000. Subsequent splits based on the additional features like age less than 30. Final tree leaf noding indicates the decisions like approve or reject. Applications and users cases. Healthcare diagnosis and classification. Predicting the presence of disease based on the patient's symptoms and testing test results. Benefits helps in early diagnosis and personalized treatments. Finances. Credit scoring and risk assessment. Evaluating loan applications by classifying applicants into categories such as high risk or low risk. Benefits enhances decision making for lending and reduces financial risk. Marketing. Customer segmentation. Segmenting customers based on purchase history, demography, and demographics and behavior to target specific market campaigns. Benefits improves marketing efficiency and personalizations of offers. Retail, inventory management and sale forecasting. Example, predicting sales for different products and managing stocks level to optimize inventory. Benefits, reduce overstock, stockouts, improves profitability. Thank you.